Hello, hello. So I figure it's time for another video for Rouge Tank. I have no idea what we're gonna do, but we're gonna do something. And so right here, boom. That looks like a bunch of repetitive nonsense, right? Let's take care of that, like right away. So we'll come here and check on what's actually happening here. I figure I should take care of this in the very same way that I took care of I believe, spawning the enemies in this one, and in Galactic Smith would have been how I spawned the ores. So let's go over here to spawner. Yep, yeah, that's exactly what I need to do. So what we're going to do is I'm going to try it more from scratch this time. So if someone needs to follow along, they can. Alright, so we're going to go into the class, group rocks. And instead of having a constructor that takes in a texture, a size, a scale, and a position, we're just going to say absolutely fuck that, right? What we're actually going to do here is just make a function that takes in no arguments. So let's do something like spawn rocks. Alright, now this is the template, so to speak. This is the header file of walls. So what we're going to do is go into, it would be model, walls in this case now. In whatever script you guys might be writing, I'm sure it's going to be organized differently. So instead of group rocks as a constructor here, we'll just say spawn rocks. It takes in no data for an argument. Yeah, there's probably an easier way to just erase all that, but I'm not too concerned about it. So what do we need? All right, we need to spawn rocks. And this needs to return void. So to spawn these rocks, let me move this microphone like this. All right. So to spawn these rocks, we need a position, right? So let's go with a minimum X and a minimum Y. So we got a minimum X position, and we're going to say let's have a max X position. And this is for the X and Y, the position of the rocks. So we know that each rock will have not just a position in this case. Yeah, I kind of wrote the the words odd up there, but it's not just a position, so to speak. It's mainly to randomize this, right? Because in spawner here, we do this scenario where we have a min and a max, and we take in a range, then we randomize between the range and the minimum. And we use that location to then set the spawn position of our object. And I believe we need to take in a very specific library here. So in spawner HPP, if we go over here, go to spawner, see if it's up here. Yep. So these two include statements are for the random. So if we come over to, it would be walls, actually HPP is where I'd like to put that. So there's our little include statement there. Now here we can have, let's say, yeah, the srand time, I think we do like a 0, something like that. That's something I learned in an introductory coding class for C++. I'm not going to act like I know exactly how that works. I do know he gave us a formula to use with it, and that's what we're going to be using today. So we have a range in the X position and a range in the Y position. What this range is going to be is equal to, I think it's like max minus min plus 1, I want to say. How that's oh, okay, yeah, I see what's going on. Wrong cap there. Let's double check this though. So over here in spawner, minus 1, not plus 1. So max minus min plus 1. Yeah, that's it right there. So not plus 1, minus 1, right? Max minus min, plus 1, or minus 1. Wow, said that wrong a couple times now. Yeah, so it's minus and minus. Again for this, and this is not T, this is Y, my bad. And these would also be Y values. So this is the range. Now so to do the random, so we're gonna just call this random X, and again for random Y, we're gonna say random X is equal to the range of X. I think it's like minus, I want to say min, the minimum of X, and then there's like a rand in there. It's like a modulo. Do rand modulo range minus min. Gotcha. And you know, so some of these things, when it comes to this, is good to look up. You know, I do not suggest memorizing very specific cases. Honestly, you can always look things up. You are coding on a computer after all. And when you write code, typically it's good to save it somewhere so you can reuse it later so you don't have to rewrite it. I'm rewriting it in this case, and I notice I've rewritten in a few places, so maybe later we'll make a whole function that'll just do this and then call that in the required places. So now that we have a range, what are we spawning, right? We need to spawn a rock. It's going to have a texture. So if we go here to group rocks, we have a rectangle shape, some colliders, code for the collider, a draw rock function, which probably honestly should be in draw. So we'll change that too. So here we're going to go into the SFML library. We're going to call for the texture. And I'm going to call it rock texture. And we're just going to load it right in through here. So rock texture dot load from file. And so this file here is going to be the PNG image. So if I go to open file and folder, go to files, and it's good practice to do it through here, especially if you have multiple copies as backups, so you don't open up the wrong one and call the wrong file, because if you do, the image will not show up. So here we've loaded the texture. Now notice I did not have it in the folder, right? So right through here, this is where it's loading from. So if you have folders or folders and folders, make sure to label that correctly. So okay, we got a texture. Let's make a sprite. So again, from the SFML, gonna go into the sprite. We're gonna call this just rock sprite. And I'm just gonna say rock sprite dot set texture, and then I'm gonna pause here. So here you can do it like this, but one thing that I just remembered is that we actually have a rectangle shape over here, and you don't necessarily need a sprite and a rectangle shape. In fact, I prefer rectangle shapes. And what we can do from there is, so this is probably my rectangle shape. This is how I typically denote those. And we can just set the texture purely to that, and it'll actually take it in as a reference. So we'll need the reference keyword. So, okay, so we have a texture, we have some randomization, we have a rock body, but we need to have multiple of these. And one thing in Spawner, we go there, we have a vector. So we have a class boss, and then we have a vector of bosses called all boss. Same thing, I'm sure, for these. We have a vector of this called this. So on and so forth. We do need this for the rocks. This will be extremely useful. So I'm going to do a hash include vector, and I'm gonna do this into the header file, because this is what the actual CPP inherits from. I'm not sure if inherits is the proper word, but I guess that's like a template for this. And one other thing we need to do I need to do in walls real quick. I say we because those who are listening may be following along. Who knows though? So we have all this, and we need a vector, and we're gonna call the group rocks, and I'm just gonna call it many rocks. That way over here we can say if many rocks dot size is not equal to 0. This way we don't throw any null exception errors if there are no rocks. So if many rocks is not equal to 0, and then we're going to do a for loop. So for, I'm going to hit tab twice, autofill. I'm going to say for int I is less than many rocks dot size. I++. And then in here, we're actually going to do be like many rocks I dot set. Be rock body dot set position. And here is where we want the random X and the random Y. But I'm actually going to have it in a SF vector 2F. And the only difference between doing it between a float and an SF vector, and I could be dead wrong, honestly, but from what I've noticed, I think one has a lot to do with pixel screen position versus regular position. I definitely probably should test it before I make any absurd assumptions like that, but that's what I figure. So okay, we have a texture set to a object. That object now has many positions. The object now needs a size. That's a get size. We want set size. Get size will just return a SF vector, I believe, or a float. In this case, yeah, SF vector. And let's see. So that rock looks pretty large. Let's go. I don't know. Let's go like 5x5 for now. We'll test it. So we got a position. We have a size. What else do we need, right? So let's take a look here at Spawner. Looks like we had a size, a scale, a position, and a texture. It'll actually look like we're setting texture per rock. So something to keep in mind. If it worked before, it's probably a good thing to follow. So we're actually just going to do many rocks in front of that. And I'd actually like to do that first, just because that makes a little more sense in my brain. You know, load the texture, then the positions, then the size, then the scale, so to speak. And we're just gonna say one by one. And I think they had what? I had like what, one more here, but okay, yeah, I see what's going on. Interesting. So we're gonna do this again. And so it looked like how I have originally been doing this. So I actually have a vector 2f in here, and we'll just call it like position, right? And that way, when we're randomizing the x and y values for a good position, instead of setting that position directly, we'll actually do saving that number like that. And I wonder too, I think it's actually better to be saved like this, but does not seem to be how I did it before, so I'm gonna trust my past self on that. Looks good. And then we're gonna use that position to actually set the position for the others. So dot many rock body dot set position, and we're just gonna do, would it be position or many rocks dot position? It's kind of a tricky one there. Yeah. In fact, would be many rocks dot position. Yeah, I am hopping back and forth. Lately, I've been working at an internship, and it does take up a lot of my time, but the good news is I get to code, and I'm learning a lot. I might not be able to use C++ currently for what I'm doing, though C#, it's useful to know. Alright, so it looks like spawn rocks. We'll do all of this. Seems decent. We're going to just take that draw function right out of there. We're going to go here into walls, find the draw function, just yoink it right out, and I'm going to go into a draw HPP, make sure walls are included, and we're going to just say void draw rocks. It's going to have to take in a render window, reference, call it window, and a rocks reference. I'm going to call it rocks. This is the template. So now that we go into draw, just going to come down here, and instead of typing void first, I found it much more useful to start the keyword with the class name, then fill out this data for the arguments, and then we want the, because once you do that, now you're down here, then you can type void and come back up. Seems somewhat efficient. Who knows though. And here we're also going to do if rocks dot all rocks or many rocks dot size is not equal to 0, and then we're going to have a for loop after that again. So for int I is less than, and if you double click, you'll actually get a whole line now, or a word, but if you like triple click, you'll get a whole line, which is something a good professor taught me. Oh yeah, we want many rocks there. Dot size. Yep, I plus boom boom, and then we're gonna say window dot draw, and we'll do our rocks dot many rocks at I dot rock body. And what that is doing is it should draw every single rock within our list. Right, so if we go back over here to window, we're literally going to yoink this right out of existence, and I'm actually just going to type some random shit there for a second. Come down here. Looks like we got a whole ton of collider code that can just be gone. And then a bunch of draw. And I want to say this red down here is from level 2. Yep. Something was here. If bullet amount. I wonder if I erased some. Oh no, that would make sense. Okay. So now our constructor is going to be much shorter. So we can just say something like this, and then from there, I'm going to set the size. So I think how did I used to do that? And by used to, like, not that long ago, but it's been a while. Resize. That is one of the best keywords for how I'm doing this. So we're going to just say rocks dot resize. We're going to resize this to the amount of rocks we want. So in this case, for the enemies, looks like we're respawning by some type of amount previously set. So above here, we could say something like int number of rocks. And we could call it, I don't know, 60. Something like that, right? And so then here we could just say num rocks. So we've resized it. You always want to resize it first. And then we could do the rocks dot many rocks. And then maybe I misspoke there. Because here it looks like, yeah. So here, this was actually a special case because reasons. It's actually kind of interesting. I have a enemy type 1, an enemy type 2, an enemy type 3, and then a function or a class called spawn that literally takes in all 3 types so that it can call from the other 3. It's I found it useful. So my mistake here though was I can actually call straight up spawn rocks. Notice how much is different here. Instead of that huge however many lines, we're down to 4. You could get this smaller. So now we come all the way down and we're going to draw these. So draw rocks, and we take in a window and a rock, and then one last thing we need to do is come up here into the collision code right here, and we're just gonna keep it similar. That way we don't have errors if there's no rocks. So if our list is not empty, for our list be rocks.many-rocks.size. And over here, I'm going to do int I instead of size t. And here we can now call our rocks.many-rocks, every rock in the list, our rock, not rock body, but so every rock in the list, and then it'd be dot get collider dot check collision. We want to check it with the players collider and have a repel force of 0. And that's it. That's literally it. We're gonna redo it in level 2. So notice how many lines that was. See if we can do a little faster this time, right? So we got group rocks. We're now gonna have some type of number of rocks, right? So int num rocks is, we'll say 50 this time, doesn't really matter. Rocks.many-rocks.resize of the num rocks, and then we will do rocks.spawn rocks. We need to come down into the collision code and take that out. So if rocks.many-rocks.size is not equal to 0. Same stuff, just very, very same. But what we're doing is cleaning up the code to be more concise. And I'm just gonna write the size here, and then I++, and then come over here to the for int I. There'd be semicolon. So for int I, there's a weird little period at the bottom. Interesting. So for int I, we would do again the rocks.many-rocks dot I would no dot, just I. So I dot get collider, check collision with the players. That's what I get for trying to go fast. Colliders 0. Alright, so there's our collider, and now we just need to draw these to the screen for level 2. So instead of all this draw code here, we can limit that to one line. Draw dot draw rocks, take in a window and a rocks. Alright, let's test it. Loading, compiling, and we have a build error. Uninitialized. Aha. So I don't know if you guys noticed, but we never set these. So this position here, I've calculated using the spawner. It's relatively this size-ish for the map. So we're going to keep within probably like 10 and 2,600 relatively for both X and Y. So for their minimum, we're just going to say is 10. And for here, we're going to say like 2,800. And let's try to run that. Uninitialized variable I used. This is the for loop I wrote by hand. Something syntax-wise is probably off. Yeah, that's what it was. I didn't have it was 0, but such is life. collision code. That many rocks. Collider check. I got this collision code from a YouTuber I was watching. It's very useful. Be able to write your own collision code. Looks like we have a successful compile. Let's look for these rocks. So far, very unimpressed with the amount of rocks. See if they're in this upper left-hand corner. They appear to not be. We're going. I'm going to say there's no rocks. Why was that? See what we got going on. Come all the way up here. We're going to close out of level 1, go to level 2 like that, and go back to level 1. Okay, so we're resizing. And then drawing. Now for the enemies. See where those are. Very similar. So we go over to draw. Find these draw enemies. Just has a for loop, 4, 4, 4. Interesting. So now we're going to compare spawner code. Looks like we loaded in texture. And just went straight for the for loop. There's actually no if statement there. Okay. Interesting. See what difference that makes. Again, I do not see any rocks. Okay. Let's check this. So in our original, we had the rand inside the for. Then we set the size, the position, and then the texture. So we'll go over here to walls. Look like we set the size, scale, the position, and then the texture was the last one. And it looks like the actual randomization never happened. Something like that. Then for the draw, we're actually going to be as identical as the spawn code as we should be. Again, no rocks. So now I'm beginning to wonder a few things. Is the rocks too small? So we have a scale, random x, random y, random x, random y. Interestingly enough, that too might be for int I is 0. I goes up to rock size, increasing with every one. Let's go back to walls. Spawning. This is the positions. That is in fact rock.png. That actually might be a funny. Right, so I did size, scale, position. Let's check this. Size, scale, position, texture. And there are textures at the bottom here. So we are randomizing. Let's go over here to window. Go all the way up. We're going to compare. Just have a spawn. Then over here, we have the draw. See if this has changed anything. If not, we're going to try to make those rocks massive. Usually they would appear in the corner for some of the errors I've seen. Oh, I do see that. I don't know if you guys can see that. Those little white squares everywhere. Those are in fact the rocks. And actually, I think I've had a very similar error before. So let's see. We load the texture. So we'll check this out. Going to walls. My bad. Yep, rocks. This here, I think might have to be inside the HPP file for starters. Secondly, something I noticed is those rocks were tiny. Something that made it actually very hard to see the actual issue. So now we'll see if they're white. If they're still white, I might be trying to spawn too many rocks at once. They're not. Perfect. Now, the collider is going to be a little funky. You can definitely see it now. So let's keep that scale 1:1. Something I noticed with walls. I should say with the collision code that I got from that YouTuber, scaling is weird. To have good collisions, as far as I can tell, the scale should be 1:1. I'll eventually have to write my own collision code to really fix that kind of stuff. But you can change the size, and you can change the size all day long. So let's go back to walls, and instead of like 10x10, we were just doing basically 30x30. Let's try 50. Do 50x50. Load it up. Boom, we got some rocks. Looks like collision's working. And I like these rocks a little bit larger, honestly. About twice as large. Yeah, so That's what appeared to be the problem. Just to reiterate, if we have, I'll show real quick. If we have in walls this SF texture, if I actually have that called straight from the HPP, all those textures will be white. And I think what's happening is it doesn't know how to handle that data properly. But if it has it as a template for whatever reason, maybe one of you guys know. If it's here for a template, then it works. It's just one of those odd things. And since they were so small, I couldn't originally see them. Actually, I think those rocks are going to it. Yeah, probably way too big. But yeah, that was a way to take some old code like we've done previously in this video series for Rouge Tank and kind of condense it a bit. We've done this with spawning, and now we've done it with the rocks, which is it's a good thing to do, honestly. Now, the rocks got so small I couldn't even find them. Right? It's a good thing. And now we can control this number of rocks very easily. And instead of going line and line and line, trying to get one more rock in, this is really a really efficient way. I've done this with interactable objects, like enemies, ores, things like that. Collidables, this can work with. Really, this is probably the best way to get in a lot of sprites that I've found. Now, I'm also not extremely experienced in coding, but yeah, I want to apologize for the lack of videos lately. As I've said, I've been rather busy. Though I'm still coding. I'm actually coming out with a Google app game that I have in the works. It's going to be very interesting. I think it's actually very fun. A little funner than Rouge Tank, to be honest. By about like, if I was to give Rouge Tank a fun rating, it's like a 2 out of 10. If I was to give this Google Play Store game that I've been working on through the internship a rating, I'd say it's 7 out of 10. To be blatantly honest, I've had 5 people play test it, and they say it's going good. So I can't show yet. Just know there's a lot coming, a lot to do. Thanks for listening.